How does the electricity supplied by the power plant manage to light up the bulbs in your home? It's not simply the flow of electrons at a large scale, but rather the transmission of the texture slope and the rhythmic circulation of energy across the entire circuit. In the conductive wire, the free electrons naturally form a free-flowing sea within the metal lattice, where the overall tension is minimal. This is their equilibrium state. When electricity is applied from the generator, it's like twisting both ends of the energy sea. One end's particle circulation rhythm is forced to change, and the surrounding texture slope is rewritten. The initially balanced textures within the wires shifted from no bias to slightly biased toward one side. And this minute asymmetry is what we recognize as voltage. This rewriting does not rely on the electrons individually traveling through the wires. Instead, it's like a chain of people holding hands. When you push from the far left, no one moves noticeably, but the motion is passed along, and quickly, the person at the far right feels the push. This is how the electric field builds up in the circuit, and the change in texture spreads almost instantaneously across the entire wire. Electrons, however, don't like staying at the biased position for long. They always seek to return to their natural free-flowing state. And the lattice doesn't like the forced asymmetry in the circulation either. Thus, the system starts to charge a tension adjustment fee. The electrons, following the textured slope, flow slightly more than usual, and the lattice immediately uses collisions and scattering to break up the ordered flow into more chaotic vibrations. These vibrations manifest as heat, and this is the resistance you feel in the wire as it slowly heats up. The material is essentially trading the flow deviation locked into the texture chain for noise, balancing the energy in the system. As long as the generator continues to generate new rhythm-altering commands, the circuit will keep redistributing the flow, turning the deviated rhythm into heat. At the light bulb, the tungsten filament acts as a structure specifically designed to absorb these rewriting costs. It is thin, long, and has high resistance, making the free-flowing state of electrons most uncomfortable in this section. Additionally, the electric field in this small section forces the electron circulation to deviate to the greatest extent. The electrons are repeatedly accelerated, repeatedly interrupted by the tungsten lattice, and the local energy sees tension oscillations intensify. In traditional physics, this process is often described as electrons colliding with the lattice, causing the tungsten filament to heat up, and then emitting light via black body radiation. In the energy filament theory, it's much more than just heating up the filament. It's as if the energy sea inside the tungsten filament is being stirred into a bubbling stew of small wrinkles. The rings of energy around the atoms and the surrounding tensions are continuously tightened and loosened. Countless small circulations oscillate at high frequencies, and these high-frequency tension oscillations eventually leak into space through the twisting actions we discussed in the third season. What you see is the continuous warm glow emitted by the filament. The most important thing to understand here is that this is not a one-time adjustment that gets resolved instantly. Instead, it's a continuous chain of events. The generator is continually sending new rhythm-altering commands, forcing electrons to deviate from their free-flowing state toward the textured slope. The wire uses resistance to dissipate this deviated rhythm into heat, and the tungsten filament at the end amplifies this adjustment, turning almost all the electrical energy into intense tension oscillations, which then transforms into heat and light. If you turn off the power, the texture slope loses its upstream input, and quickly, the free will of the material causes it to flatten out. The electrons return to the most energy-efficient symmetrical circulation, and the filament cools, causing the light to go out. Thus, the transfer of electrical energy is a process of continuously adjusting the textured slopes in the energy sea, followed by their dissipation. Electricity is simply the manifestation of forcing structures to deviate from their natural free state through these slopes. Tap follow, share it on New Physics, Clear Universe. Join us in our series of new physics videos as we take you on a journey to see the universe in a completely different way.